When Falcon 9 completes its 31st reignition and landing, and Starlink dominates half of the low Earth orbit, SpaceX has defined the rules of the game for reusable rockets in a decade. And just today, December 23, 2025, China's Long March 12A, CZ-12A, completed its maiden flight amid debates, joining Zhu K3 to form the dual trials of China's pursuit in the global reusable rocket race. For global space enthusiasts, these two missions are crucial signs of how China is catching up with SpaceX. 10 days ago, a roar echoed in the Gobi Desert. LandSpace Zhu K3 completed its maiden flight. With a 66.1-meter stainless steel body and 770-ton takeoff thrust, it successfully sent payloads into the intended orbit, but crashed 40 meters above the ground due to braking failure. This successful failure just lifted the curtain on China's pursuit. What's worth noting is that China did not repeat SpaceX's kerosene fuel route, but directly adopted methalox, liquid oxygen-methane, fuel, aligning with the technical architecture of SpaceX's Starship. This choice puts China at a higher starting point, but also faces a steeper technical challenge. If Zhu K3 is a bold attempt by a private space company, the Long March 12A is a precise strike by China's state-owned space sector. But this high-stakes gamble of recycling on the first flight ultimately left half a regret. This 62-meter methalox rocket, equipped with 7 Longyun engines, successfully sent 2 satellites into low Earth orbit from Jiuquan this morning, but encountered an emergency during the first stage recovery, 4 kilometers above the ground. The engine ignited abnormally, with flames wrapping the rocket body in reverse. Coupled with the failure of one engine to restart and strong crosswinds interfering with grid fin control, the rocket finally crashed and exploded at a speed exceeding safety standards. Despite the failure, it still verified the clean adaptability of methalox fuel and the precise guidance capability of China's Tianshu navigation system. The landing point did not deviate far from the recovery site. Many global audiences ask, do these two failures mean a huge gap between China and SpaceX? The answer is, the gap is real, but trial and error is an inevitable path of pursuit. Falcon 9 experienced 24 consecutive failures before achieving today's high success rate. China's 2 failures have exactly exposed the core bottlenecks of reusable rockets: the reliability of deep throttle engines, attitude control under extreme conditions, and accurate prediction of high-altitude wind fields. The 75% to 100% thrust adjustment range of the Long March 12A's engines and the coordinated control of Zhu K3's 9 parallel engines are world-class challenges. However, China skipped Falcon 9's early kerosene route and directly tackled the more advanced methalox technology. This latecomer advantage in technical selection has shortened the gap from a decade to the final mile. This pursuit is never a single-point breakthrough, nor a lonely journey. While LandSpace reviews the wind field prediction deviation of Zhu K3, the Long March 12A team is investigating the defects of the engine thrust adjustment algorithm. When the state-owned space sector builds a cross-regional TTZ-to-C network, the commercial space industry's industrial chain, such as 3D printing and stainless steel rocket bodies, is maturing rapidly. Behind this is the demand for deploying over 10,000 low Earth orbit satellites. In the next decade, China needs an average of 7 launches per day to complete the deployment, which is the mission that reusable rockets must overcome. SpaceX iterates technology through high-frequency launches, while China relies on the world's most complete aerospace industrial system to take a unique path of state-owned enterprises laying the foundation and private enterprises innovating. Every failure paves the way for the next success. SpaceX's success was never achieved overnight. Reusable rockets are inherently technologies iterated through explosions. Today, Zhu K3's braking failure and Long March 12A's engine anomaly are not the end. The latter has planned 2 to 3 special recovery verifications in the first half of 2026, focusing on optimizing core challenges. From the Gobi to the ocean, from private enterprises to state-owned teams, this pursuit is not about copying, but about gaining China's right to speak in the race to the stars and the sea. Failure is temporary, but China's aerospace pace towards the low-cost space era has never stopped. The next ignition may be the breakthrough moment of that final mile.